Welcome back to the Generative VQA series. So far we have explored first, we have an introduction about the VQA, their type and the core challenges. In the next video, we have discussed about the complete architecture that we are going to build. That is, we will use clip for images, GPT-2 for questions and a GRU decoder. In the third video in this set, we have a full breakdown of the VQA2 dataset which we are going to use. Now in this video, we step into the actual implementation. And here's the catch. Most VQA datasets are dominated by one word answer. For example, yes, no, red, true. But a generative VQA needs answer with depth. It needs responses that unfold token by token, not tiny labels. So in this video, I'll show you how I create a focused mini dataset from the large VQAv2 that include only descriptive answer, at least 3 words long. This approach prepares our pipeline for the real generative visual question answer training. So first of all, let's start by importing all the libraries which we need. And here we don't need any major library. These are some small library like operating system for the paths, then JSON to read and write JSON file, because our VQA dataset has JSON file, then some random to do some random stuff. Then we have shuttle to copy files, I think that we need because the dataset contain images. So we also going to like copy those images into our another folder. So we just have a small data set that is portable enough. It should have its question, answer, and it's all images, so that we don't need anything else beside that. Then we have pandas, then a TQDM, that is the progress bar. Now start with the configuration. So let me paste all the things for this configuration part. Okay, so this part simply sets a path for the original Coco images. Here you can see image dir. It basically refer to the Coco 2014 training images, because the VQA v2 dataset uses Coco images. And let me show you that specific folder. So here's that folder, the Coco 2014, and it has 3 folders, and the one which we need is train 2014, and it contain around 82k images. And if it able to load those images, I can show you a few samples. So let's move on to the code. We can see a few samples later. Then we have another directory which points to the VQA version 2 dataset. In the meantime, let's see that. So here's our VQA version 2 dataset and all its annotation file. And we only need 2 files here. First is this open-ended ms coco train 24 questions.json, because this file contains the question, and I'll try to show you. And it's a kind of large file, so it would take time. I hope you can see things here, and if not, so it basically for each of the thing, if you just look at this specific thing which I'm highlighting, so it would contain an image ID, a question, and a question ID. So this is how it would work, and we will use image ID to get the image name, and we have a question here, and the question ID would basically help us to find the answer for this question, which is in the annotation file. Let me show you the annotation file, and this is the annotation file, ms coco train 2014 annotation.json, and this file is really long. It's about 355 MB, so there's no advantage to load it. So for each question it has 10 answer, and we are going to choose one answer out of them. So here are few images from the Coco 2014 dataset. So it's gonna take a bit of time to load, because all these images are stored in the external hard drive, and that is a hard drive, not SSD. So its speed is low. You can see different kind of images. So these are a few samples. Let's move back to our code. So it's kind of stuck. Let's move the code. So this part simply sets up the path for original Coco images, the VQA dataset, and we also have the question JSON file pointing, and then annotation file, and then a folder, the output dir, where we are going to store our filtered dataset. And let's also create that folder just to be sure that this folder exists. So let me run this for now just to be sure we are doing something proper. Okay, so it's working and we have a folder. Okay, so things are working. So I created an images folder inside it also, because inside it we're going to store the images for which we have question and answer. We are not going to store all images. So our next part is going to load the original VQA dataset. So here in these lines, we load the original question and annotation file. So here see, we are opening the question path, which is basically this JSON file. So we open it and then we use JSON library to load all the questions. Basically the question file, not the questions. So questions basically means the question file. It contain all the data. Then we, in the same way, we load the annotation.json file. And here we build a mapping from question ID to annotation. So for each annotation, we have ANN, and from the ANN we find the question ID. Okay. So before this, let me show you how each of the data look. Okay, that would be much better approach. Besides just simply printing it, and it would be a lot of data, I believe. It would fill the, see if it would fill the screen. Okay, I've interrupted it. So you can see, you just need to take a look at this just one data point. It contain again same image ID, question, and the question ID. So it has question ID. So this question ID is a common factor. Same with annotations. So let me just point out to one item from this annotation instead of loading the whole list. Okay. So you can see question type. What is this? Multiple choice net answers. Okay. And then we have answers. So this is our main thing which we need. Okay. I think for each answer, each question it has 10 answer. Answer is net, answer confidence, answer ID. Then again it has answer net. Okay, then answer confidence. So like this. At the end it contain image ID, answer type, and a question ID. So just look at the main thing. First is the answers. It is a list of 10 till here. It has image ID, maybe we'll use it. Then it has the question ID. This is the important thing which we need. So leave the rest. Don't get confused. So now, so now we are going to build a mapping from question ID to annotation. So let's also print this. So it's simple. Here we loop over all the annotation, and inside each annotation, we point out this question ID. Okay, so let me also print it. How this looks. So here each annotation also reference to the same question using the same using question ID. So question ID is the main, but as you've seen, it contain multiple answers. So you can see it's running. So you can see it's giving a lot of data set. So we're gonna later use it. Or if you want, it's simple. Just load the one data point. Like, why haven't I done that? Oh, this is not how it would work. I think it would need a question ID. And if I go above, it's, so let's see it later, because this is huge. So simply see that with this we are building a mapping from question ID to annotation, because that is important. Next, what we're gonna do, we are going to merge these two pieces together. Okay, that is merging question and answer, and this is the heart of this script, because for each question we only want one final answer, and that answer should be descriptive. So let's do that, and let me paste the entire code. Okay, so here's the main part of this code. We're merging the question answer. So here we have an empty list, and here we loop over to all the questions. So here we have a dictionary. Okay, and in this dictionary I have told you that we need to give a question ID. So this QID to ANN dot get, we give it a question ID, and it would give us the annotation. If annotation is not, if not annotation is, then continue. Okay, then go to the loop again, don't follow this. Now we'll take, what do we do, we, so it would give us the most it would give us all answers, but we would take the most frequent answer. If we would take the answer which is occurring multiple time or majority of time answer. So how it work, we'll have this. So for A in NN answer, so it would give us all the answer which we have seen, and if A answer strip, if it is not blank, then it would give you the answer. So we have all the answers here. Okay, so in this it would give all the answers. Let me just do one thing for you, let me print it, that would be much better. Otherwise what's the point of showing to you? And we can also break it so that it won't go like loop, because like it load a lot of data and it take time and like occupy the complete screen. So you can say for the first question, these are the 10 answers. Okay, now what we need to do, we need to take out the most frequent answer. So first of all, what do we check? It should have something. If it does not, then again continue to the loop, don't go to the next part. Next, max main answer. Now what do we do? We have all the answer, we create a set basically, it does not, it would not have any duplicate answers. See, I'll print it, and we're gonna do a break, and I hope it should run, it should not give us any error. Yeah, you can see we only have unique answers. Got it? Now we have all unique answer, and key is answer dot count. So count is basically their length. So which one have maximum is the main answer. This is how it works, and I also print it out for you. And again a break statement, we don't want to loop, we don't want to get in that loop. Okay, net is the answer we have. Let's remove this break and let it run multiple times and see what do we get. So you can see these are answers for all the question, and you can see many of them are one word, and this is what we want to remove from this data set. Like if you are working on a generative VQA, you want a token by token answer, but how are you going to generate a token if you have only one token? So your model would not be able to train, and it would not be able to give you even basic decent answers. Okay, so for that we need at least 3 words which I have chosen, that this is my threshold. You can choose 5, 6, depending upon you. But like, I don't want to take one word or two word answer, because they basically come in the category of descriptive VQA, and here we are working with generative VQA. So we need some descriptive answer. Those answer that could be generated via token by token, which forms a kind of language, a sentence, which the model learned to generate over time. So that is why I have shown you answers here. See, bike and bus. This, if we have some image and the question is what are the object in the image, and the model says bike and bus, so it makes sense to generate them using token by token way. So these are the main answers. Now here, what do we check? Their length. We split it. Okay, so it would become a list, and if the length of this list is greater than 3, then only we're gonna append that data into our list. So let me just show you an example, like in here only. Let's say your main answer is equal to, let's say for now it is red, so it's gonna split it using this split function. So what would it become? It would become a list of red, because its length is less than or equal to 3, so it would not be appended. And let's say, in case if your main answer is equals to what, it has bus and car, then what it would become? It would become a list of bus and car. So now in case where your main answer is bus and car, it would split, have a list, and it has 3 word, and which fulfills our condition, and this example, this answer would be appended into the merged data. So in our merged data, what we would have? We would have image ID, question, and our main answer. So we are not choosing all the 10 answer. We are just taking one main answer, because this is a simple project. And also, I don't have that computation power to run everything. So I just want to do simple thing, do simple stuff, because I'm using a 1050 Ti. Okay, so we'll be making sure that things are simple so that they can even run on 1050 Ti. Okay, so I think this much part is easier. Okay, so now what do we have? We have ensured that in the merged data, we have all those questions which have an answer length of at least 3 or greater. So now our data set is descriptive. So this filter basically removed yes no question and one word classification answer. So what remains is a high quality descriptive data set that would be good for our generative VQA. Now in the next part, what do we have? We're going to copy and save all the images. So before that, let's print how many questions do we have, because that is also important now to know. Okay, so we have 9172 questions. See how many question it has: 1, 10, 100, 1000, 10,000, lakh. So it has 4.4 lakh questions. And how many we have filtered out? 9172, not even 10k. Got it? So this is kind of mini VQA for generative VQA. That is why if you train your generative VQA on this complete data set, it would not have good result, because most of them are less than or equals to 2 word. So that's why we are creating a sub data set. We are creating a focused data set for generative VQA. So now let's move on to copying images. Okay, so we have empty list final data. Then on the merged data, we loop it over. And so what do we need here is the image ID to get the image name and then the path. So we need two paths, source path and the destination path. Source path from where we're gonna copy, and destination path where we're gonna paste it. Okay. So we have a image name, and this image name have a specific pattern. Okay. So it has an image ID. We have image ID associated with each question, and we have this string Coco train 24 item, and then JPG. So this make sure it has 12 zeros. Okay, 12 zeros, and rest like from the right side, though these would be filled by image ID. Let me show you how it look here. If we can load one image at least, so we can see, because it follows specific pattern, and hope you understood it, so that until time we can wait. So now we check if the source path exists, that image exists or not. First of all, we check that. If it does not exist, then this is not good for us. So we need to remove that question that answer everything, because we don't have an image. So if that exists, we copy it to our destination folder, and we copy its path. This is the image path for with respect to our data set, that is images and the image name. So image name also contain extension complete image name. I hope okay. Just one image I need, just one. This is taking time. Okay, you can see it contains 0 0 0 0 multiple 0. So basically 12 numbers they have, I think, and some of them are filled by 0 from the right side, not the zeros, some numbers from the right side. So this is its way to having image names, and we don't have anything option to change it. So this is special. I hope you got it. It's not that difficult. And now we have our final data set. Okay. So let's also like copy that line and see how many images total question answer we have in our in the final data set. Is there any image which we are not able to find? Let's also make sure. This is a kind of a check. So this would take time, and yeah. So let's do it after some time, because this would take time, and if it's taking time, let's delete this also. And if it's taking time, then we'll complete the rest of the thing. So now what do? We need to save these thing into some file, because we have already write the code to copy all the images and save them. Now what do? We're gonna save them as a JSON and a CSV. So we have an output dir where we're going to have a question answer JSON, and we have the final data save in the JSON format. Next, we're going to save the same thing in form of a CSV. So this is not that much. So these two files fully describe our new mini VQA version 2 dataset. The JSON file is basically great for training script, and the CSV is perfect for quick inspection, because with one thing I personally like is have most of the data in a CSV, so that I can easily open that file anywhere. Like if you want to read from a JSON file, it would be difficult, but if you read it from a CSV, it's much easier on any device. Even on your mobile, you can open a CSV file easily with Excel or Google Sheet, but these JSON files are kind of difficult to open. So now we can run this, because our complete code is done. So let me run this and we'll check how it's performing. And it would take some time. You can see 2 minutes. So for the time, I'll pause and then we'll come again. So this process is done. And so initially it was 9300 images, then again we have 9300. There's some change. If you see above, it was 9172 and here it is 93. This is like, what is this? There's some change, some random thing is going on. Even I don't know, even I am surprised to see it. But at last we have, you can say, around 9k data points for our generative VQA. And let me show you the folder now. Not this one. This one is really heavy and it take a lot of resources to load it and then run other files. Like this is mess up. I can't do anything, just to wait, because that hard disk is important. I don't want to lose my 8 TB of external hard disk, because I've already lost one time, but that time I have the option to recover it. So that was good. But for now, I just only use it when required. Okay, so we are in our mini VQA. Let me give it a little zoom. Okay, so inside we have images. Let me reload them. So here we have 8203 images. Okay, and here is our beta.csv, and then we have question answer pair.csv. So let me stuck so badly. Okay, so your image ID, question ID, then question, then answer, and then image path. So dataset is simple, and the best thing is, still if you see, it's not like too much, you would say, a descriptive answer. These are still some words. It's not a complete sentence. Like it should be like the answer is white and purple. It would be better. It's like the image, the question is what is the color of toothbrush. So it should be the color of toothbrush is white and purple. That would be a complete answer. But here it's like simple and short, and that would be good for our task. Because again, same thing, resources are not there, just say 1050 4 GB. So in that case things are fine. Maybe when I have some resources, then I can train something much better. Okay, let's also try to load this question answer file. Okay, now we have, now see, with small files things work fine. Let me just zoom it in a bit. Yeah, so we have, for each data point we have an image ID, same thing, question ID and a question and an associated answer. And so see, so, and that ends the data preparation step of our generative VQA. And now we have a compact descriptive generative friendly version of VQA version 2 with clean question, meaningful answer, and only the images which we need. So this is a small subset of VQA version 2. So that's all for this video. And in the next video, we'll move to the most exciting part, building generative VQA model itself. We will implement its full pipeline. That is, we are going to use clip as the image encoder, GPT-2 as the question encoder, and a GRU decoder to generate answers step by step. If you are enjoying this series, subscribe and follow along. The real magic begins in the next episode. Thank you. Have a nice day.